Okay, so again, this lesson will be kind of a work in class lesson. Make sure you have 8.3 done. We're going to review tomorrow before the test. This lesson kind of starts off with something nice that's a skill that we maybe haven't used in a while. So the top one I have an example of, quite a bit easier than the ones on bottom. So you can see we just set up our cross products the same, 5 times the quantity x minus 1, and then I have 2x times 3. We set them equal. We combine our like terms, we solve, and we get x equals -5. Number 4 on the bottom, and the way the rest of the bottom ones look, however, is quite a bit different. So I'm going to really zoom in on this. So we set up our cross products the same, but once we do that, you'll notice that we have an x squared term that doesn't cancel out. So when we do this, what we want to do is we want to get all of this stuff on the same side. So when we do that, you can see this line here. It's ideal for our leading coefficient to be +1. And then we can do something called two-step factoring that you guys probably haven't seen since last year. So the way two-step factoring works is, again, we want the multiples of our last term, which I listed them out. It's just 1 and 5 that add up to the middle term 6. So once we get our two multiples that work, we just put them into the formula x plus 1, x plus 5. And now I can set each of these things equal to 0 using the zero product property rule, and I get my two solutions. So if you want to pause and try some of those, you sure can. I'll refresh your memory on how to solve those. But if you want to pause and try 2, 3, 5, and 6, or a couple or one of each, whatever, I'm just going to scroll through so that you can see the answers. Okay, so again, anytime you have x squared in your term, you're going to end up with at least 2 answers. So whatever that power is on the x, that's how many answers you have. So this unit's on proportionality theorems. Again, we've done all those similarity statements. Proportions and those scale factors are kind of the same thing once we get things set up. So it says use the triangle proportionality theorem and its converse. So here it is. Again, pause this, copy it down. I'm going to scroll for the sake of time. But basically what it says is if we have a triangle and we have parallel lines, that we don't have to do the full triangle for the proportionality statements. We can just do the parts. So I can say RT over TQ should be equal to RU over US. And the converse is true as well. So if RT over TQ is the same as RU over US, then we know these two lines here have to be parallel. So in this one, it says we want to find the length of QR or RQ, whatever you want to call it. We're going to use that proportionality theorem. So we have X over the remaining segment 9. Again, it's nice to write out the statements. So we have RQ over QU should be equal to RS over ST. Now we can plug those in over here. Again, setting up those cross products, we get 6x equals 9 times 4. We get 6x equals 36. We divide by 6. We get x equals 6. Okay, so again, just set up those proportions. Okay, pause, go ahead, try this. You guys make sure you set up your cross products. So again, I'll let you guys work this out. It should be WX or XW, whatever you want to call it. So we should have XW over WV should equal XY over YZ. And when we set that up, it should be 44 over 35 equals 36 over what we don't know. Again, we can set up our cross products, and I'll let you guys multiply this out. Again, I don't have my calculator handy. You guys can multiply that out and get that, but that's how you would solve that cross product. Again, we have a shoe rack here. They're trying to see if it says on the shoe rack BA is 33 centimeters, and then it says CB is 27. And then it says CD is 44 and DE is 25. And it wants to know that the thing is not parallel to the floor. Well, again, our cross products have to be equal in order for that to be the case. So 27 over 33 would have to be equal to 44 over 25. And without even reducing, we can pretty clearly tell that that's not the case. I can reduce 27 over 33 and make that make sense. But just the fact that it's little over big on the one side and big over little on the other, it should be pretty obvious for us to say that no, that shoe rack is not parallel to the floor. Okay, so again, monitoring progress here, we want to decide whether those cross products are proportional. So we have 72 over 40 is equal to 90 over 50. So basically, if I can reduce 72 over 40 to 9 over 5, I can say those are proportional. So if I divide 72, let's see, I can divide that by 8, and I can divide this by 8. 72 divided by 8 is 9, 40 divided by 8 is 5. So those do indeed end up equaling each other. You could have also done the cross products to see that they're equal as well. Either way works just fine. We have to show that they're equal. Okay, three parallel lines theorem. Again, it's kind of that proportionality statement again. So we don't necessarily have to have a closed triangle. We can do it if we have parallel lines all the way through. Again, those two transversals really don't ever have to touch. They will eventually, obviously, but it just says if we know we have parallel lines all the way through, those proportions should be the same. So on this one, again, our parallel lines are HC, GD, and FE. It says in the diagram, angles 1, 2, and 3 are congruent. Those are corresponding angles. That gives us parallel lines. It says that GF is 120. That's labeled. It says that DE is 150. It says DC or CD is 300. And we're supposed to find the length of HF. Now in our proportions, we're just going to find HG. So we're going to have 120 over we don't know is equal to 150 over 300. Now I can reduce this right here and make life a lot easier. 150 over 300 is just going to be 1 over 2. So if I do my cross products, I just get 240 for that. Now 240 is just this length right here. They asked for from H clear to F. So when we add those up, we get 360 yards. Again, make sure we read the directions carefully because that helps us answer that question correctly. Okay, another theorem, we have triangle angle bisector theorem. It says if a ray bisects any angle of the triangle, then the ratio of the leg over, I want to be able to phrase this correctly. It's the ratio of the side that is being bisected over the other side being bisected is equal to the adjacent over the adjacent. Okay, so again, it's kind of a weird one, but we're going to use kind of the side bisected and the adjacent side to the angle. Remember, the term adjacent means next to. So that side is next to the angle on that one. This side is next to the angle on that one. Okay, so in our example here, we have our side that's being bisected. Now this one's kind of a tough one because we're going to end up with multiple x's. So let's label our segments first. P is being bisected. We have RS over the other side, QR, should be equal to 13 because that's the adjacent side where RS is over, well, and let's call it PS to start with. Before we plug in numbers, we'll call it PS over PQ. So side adjacent to X, side adjacent to QR on the other side. So now when I go to plug this in, RS is easy to plug in for. Let's see, QR, we have kind of an issue here because we know the whole thing is 15, and we only know what this is, it's X. So we have to call this 15 minus X. Okay, we know what PS is, that's 13. We know what PQ is. That's 7. Now we do our cross products. So we have 7x equals 13 times 15 minus x. Okay, so when I multiply that through, let's see, 15 times 13, we have 5, 1, 3, 4, 0, 5, 1. We drop the 5, so we get 195. Okay, so now we have 7x equals 195 minus 13x. When I add this over, I get 20x equals 195. And this is going to be a decimal. You guys can solve that out. It's going to be a decimal there for that side length, though. So if it wants us to find RS, let me punch this in my phone really quick just to make sure. Excuse me, pardon me. So we have 195 divided by 20. We get 9.75. So that would be the length of RS there, 9.75. Again, the tricky part there is making sure that we pull from those sides. So like it suggests right here, it says we want the side that's being bisected over the other side that's being bisected is equal to the adjacent side over the adjacent side. So going back and making sure we set that up right. It was the bottom side being bisected over the top side being bisected is equal to the adjacent side over the adjacent side. So it looks like we set that up right. Okay, our last little bit here of monitoring progress. Again, we're just solving for the missing parts that they're asking for using those theorems that we just talked about. So I'm just going to work them out. Again, you guys can pause it and work it out too. But this one is going to be 16 over 40 is equal to, we don't know, over 30. Again, we do our cross products, so we get 40x is equal to 16 times 30. We divide that 40 over. So I'm going to punch that in real quick. 16 times 30 divided by 40, we get 12. Okay. Again, we set up our proportions here. So we have 16 over x is equal to 15 over 18. We do our cross products. 15x is equal to 16 times 18. So I'm going to go 16 times 18 divided by 15. And again, we get a decimal here, which is fine. We get x equals 19.2. Okay, this one, again, the setup is side bisected over side bisected. Now, it doesn't really matter which one. I like x on the top left, so I'm going to put x over 14. So when I do that, I'm going to put 48 on top on the other side and 24 on bottom. So again, I do my cross products. I get 24x is equal to 14 times 48. Again, you can simplify along the way. I'm just going to punch it in really quick. So 14 times 48 divided by 24, and I get x is equal to 28. Last one here, and again, this one's nice because it has a square root that we haven't worked with in a while, so let's look at this one. So I'm going to go adjacent over adjacent, or excuse me, bisected over bisected is equal to adjacent over adjacent. Now this one, this should be pretty obvious. If I do my cross products, that's great, and I don't need to worry about it. But if I need my fractions to equal 1 on either side, my answer for this is just going to be y is equal to 4 times the square root of 2. Okay, so again, this is in essence what happens when you have a square in the coordinate plane or trying to count the length of this. This is actually a right angle here, and we'll learn more about those right triangle properties here pretty soon. So again, the triangle proportionality theorem and its converse we used, and then a couple other proportionality theorems with parallel lines and triangles, angles bisected. Make sure you guys ask questions if you have them. The assignment's posted and ready for you guys to work on that practice set. Again, keep in mind we're going to review for our test before the end of the quarter tomorrow. Thanks, guys. Have a great day.